So hello everyone, welcome to our new video, and today we are going to learn about STL in C++. So now what does STL stands for? STL stands for Standard Template Library. Now this is a library which has many different type of data structures, many classes and many algorithms which we can use while writing a program or while developing anything. The basic algorithms or data structures which are needed to be created every time, those have been already created by the developers of C++, and it has been kept in the STL, so that whenever it is required, the programmer can use it whenever it is required accordingly. Okay, so today we are going to learn about that. So now let me start with the very basics. So the most basic data structure that we come across every day is arrays. How do we declare an array? So I have written a basic program here. This is the way how we declare an array, right? And this is called as the static memory allocation of arrays. I have created an array, I have given the size as 5, and then I am giving, and then I have initialized it with 5 different values, and here I have a fun function which is going to print all the elements of this array, right? And I am calling this fun function, and this is printing all the values. This is it, the normal way. Let me execute this, and let's see here. It is printing all the values that I have in the array 1, 2, 3, 4 and 5. Now this is the static way. So now what is the problem actually here in this case? This is fixed size. This size has been assigned as soon as the program starts. So I cannot add any more values. Not only about adding any more values, I cannot even take the input from the user in case of statically allocating the memory. Now if I want to do this dynamically, then in that case I will be taking the input from the user, that what is the size of the array that you want to make, and then I will take the input from the user, right? So here let's make it dynamically. So how we are going to do it dynamically? I have created a variable n, then I am going to take the input from the user, whatever be the value for n. Then for creating it dynamically, how do we create? So this is the data type here. Now here I have to give a star ARR, then equal to new int, and the size here, the size is given by the user as n, so the size here is n. Now what will I do? I will take a for loop, int I equal to 0, I less than n, I plus plus, and then at every iteration I will be taking the input from the user. So int data variable I have taken, c in data, and at that particular index ARR of I will be storing the data there, right? This is it. So now if I have to use this fun function, so I have to pass the value here as n, and this is how it is going to work. Okay, no problem. I have to give the size here, let us say 5, values I have given, these are the values that I have given here. So 6, 7, 2, 3 and 0, it is working perfect. Now my point here is, what if the user wants to give some more values? Then in that case, how are we going to do that? Even if I try to insert some more values here, let's say I will take another for loop here, for int I equal to 0, I less than, let's say I want to give it 10 more values, I plus plus, then in that case everywhere at n plus I, okay, n means whatever the values we had till now, plus I means it is starting from 0 and it will go for some more values here. Everywhere I am storing a value here, let's say as 7. Done. Now and here I will pass the value as n plus 10. Now let us see how it works. If I execute this, I have given the size here as 5. Done. My values are 1, 2, 3, 4 and 5. As soon as I do this, after this it will try to, as soon as I press the enter button, it will start assigning the value 7 for 10 more locations here. So here you can see till 5 the values were stored. After that it stored some values here as 777 and it has, but it has stopped here without exit code 0, a negative number it is showing here. It means it has not exited successfully. So there was some problem definitely. It is not, we are not allowed to do this, right? So what did the developers do? They developed something called as vectors here. Now what is a vector? It is similar to arrays, but the size there is not at all fixed. We can insert there as many values as we want, and it is not even necessary to declare the size of the vector while creating a vector. So now let's just go and let's see how we are going to deal with vectors. So here the most important thing for using vectors, we have to include the vector header file here. Then after that, for creating a vector, simply we have to write the statement vector. Then after vectors we have to write it inside angular brackets as int, and the name of the vector, I have given the name of the vector here as v. That's it. We don't even have to give the size. Initialization is also not necessary here. Even if we are not giving the size, then how are we going to initialize it? So this is it. This is how we can create a vector. After creating a vector, we can assign the values by using this function v dot pushback. So here I have written the statement v dot pushback 1, pushback 2, 3, 4, 5 and 6. I have inserted here 6 values, you can see here. So now after this I have created a print function here. Now inside the print function also, it is not necessary to give the size. I am only sending here the vector. After taking the vector, by using the size function v dot size, we can find out the size. And in the similar way how we print the elements in a array, similarly we have to print the element here for the vector also. Cout, you can see here that I have written here as v of I, and at every iteration it will keep on printing all the elements. Now rather than that, if you don't want to use this, then we can also use the statement here as cout v dot at I means whatever with the specified index here. So now let's just see here how it works, and then after that I am calling here the print function. So I had inserted this 6 elements, so it is printing the 6 elements here. If I write the other statement, if I don't consider this statement in it, and if I consider the other one as v dot at I, so this one is also going to work here in the same way as 1, 2, 3, 4, 5 and 6. So now our main point is how it is working here. How is the vector working? Whenever I am trying to insert a new value, it is inserting all the values here as it is. Now suppose if I comment this 4 lines, 3, 4, 5 and 6 are not there. Now if I execute them, so I have only 2 elements in the vector here. So it is printing here just the 2 vectors 1 and 2. If I uncomment this 2 lines also, so now in this case it will be printing the first 4 elements 1, 2, 3 and 4. So my point here is how is it actually working. So here in case of vectors there are 2 different things. One is the size and the other thing is capacity. Size means how many values do we actually have right now. Capacity means how many more values can we store there in a vector. As soon as we insert one element, so the size is also 1, the capacity is also 1. As soon as we insert the second element, the size is 2, the capacity is also 2. But as soon as we insert the third element, the size is 3, but the capacity becomes 4. So what actually happens here, every time whenever the size of the vector is equal to the capacity, when the size equals the capacity automatically doubles there for a vector. Okay. So let's just take an example and I will show you how it is actually working here. So here what have I done? I have taken an infinite while loop, okay, and here I have a variable d, I am taking the input. Now whatever the user gives the input, I am pushing the element in the vector v dot pushback d. This is how we insert the elements into a vector, okay. Then after that what am I doing here? I am printing out every time the capacity. How do we get the capacity? By writing there as V dot capacity, and then I am also getting the size here as V dot size here, okay, and this is it, what is going on here every time. So just look here how it works. The first element that I enter here is 1, so capacity is 1, size is 1. Second element 2, capacity 2, size is 2. As soon as I enter the third element, the capacity was doubled to 4 here, 4, it is okay. Next element I gave here 5, now the capacity directly got doubled here as 8. Let us say 6, 7, 8, till 8 elements, the size is 8 and the capacity is also 8. As soon as I give the next element, let us say 9, so now the size, now the size here remains as 9, but the capacity has doubled here to 16. This is how it is working. This is how the vector actually works. The vectors in STL, it gives us the freedom to focus on the program rather than focusing on designing a proper array. We don't have to focus on that. We can easily use a vector and we can keep on using it. We can keep on inserting the values. We can keep on removing the values however we want there, okay. So till here we learned about how to enter the elements into a vector. Now our next task is to delete the elements. So how are we going to delete the elements? We have pushback function, which enters a new element into the vector. Similarly, we have a popback function which deletes the element from the vector here, okay. So now pushback and popback. Pushback enters a new element every time at the end, and similarly popback deletes the value every time from the end, not from anywhere else. From the end it works here, okay. So now what I did here, first I have pushed here 3 elements 1, 2 and 3. Then I am printing the entire vector here by calling the print function, and for popping it out we simply have to write here as v dot popback, okay. So now let us execute this and see. First I inserted 3 elements, then I have printed it here, right. Execute this. So here I have the values. First I had 1, 2 and 3, then afterwards when I popped out the value, I have only 1 and 2 here. Now what if I try to pop out some more values here? I had total 3 values, but I am writing the popback function here 4 times. So now in this case, if I remove one, suppose if we have only 3, so in this case it will be working as perfect. First we will have 1, 2 and 3, then 1, 2, then 1, and then the third time it is empty here. But here if I write it again for the 4th time, now this time it is going to throw us an error that terminate called after throwing an instance, that bad array new length. This is what it throws here, right, when we are trying to pop out any element from a vector which is already empty. So this is how the popback function works here. So now here our next thing is about vector initialization. Now how do we create a vector? As I have told you already before, that vector, then the data type, and after that the name. I have given the name here as ARR. This is a default vector with no data and 0 size, right. Now what if, suppose if I want to give the size, and if I want to initialize the vector here, then in that case it will remain the same, and along with that here this is how we initialize it and how we give the size 5 comma minus 1. Here the size of the array here is 5, and the values, all the values in the vector, all those 5 values, they are initialized with the size here as, they are initialized with the value here as minus 1. Now there is another way of initializing it by writing it simply like a normal array here as 1 comma 2 comma 3 comma 4 comma 5 inside curly brackets, okay. Or the same thing we can also write it here as like this without giving the equal sign. This is also going to work in the same way. If I print this out here, you can see that it is printing all the values here 1, 2, 3, 4 and 5, how they were stored in the vector ARR4, right. Now our next thing here is about how to copy an entire vector. We know that an array cannot be copied directly, right? We cannot do that. But here we can copy a vector directly. Suppose if I have created a array here ARR of 5 which has this 5 values 1, 2, 3, 4 and 5. Now if I want to copy this entire vector into another vector as ARR 6, so vector int ARR 6 and inside brackets I have written here as ARR 5. Now after that if I try to print this ARR 6 here, so you can see here that all the values are getting printed exactly how they were in vector ARR of 5. The same thing is printed here exactly as ARR of 6. Okay. So this is it all. So this is all about for today. In the next video I will be covering some other things in which are there in STL like stacks, queues, maps and list. These 4 things I will be covering in the next video. So if you have any doubts till now, please go and watch the video again, and even then if your doubts are not cleared, then give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, click the like button because that gives us a motivation to record a new video every time. And if you have not subscribed to our channel yet, then please do subscribe to our channel and don't forget to press the bell icon so that you get a notification when I am going to upload the next part of this video. So okay, so thank you very much, keep learning.